Yeah, I can see it.
Okay. Just I'm putting it on the screen. So it's end behavior. What I mean to say, that is all about the functions. So we will discuss the end behavior of the functions graphically, and then at the end we will talk about how to find the end behavior of function algebraically. Now let's see.
Okay.
The first is that we should define what is end behavior. So end behavior of polynomials. So these are basically the functions. So different type of the functions are given, and definitely I have seen all those screenshots from Delta Math. So they were just asking for the end behavior of each and every function. Are you
Right.
getting me? Are you
Yeah.
getting me? Okay. So at the end, we will see all those, and we will try to solve all those type of the functions and to get the right answers for their end behaviors. So let's see. Actually, when you know how to find it, what is that, then you will be in a better position to solve so many questions about the end behavior. So whatsoever the screenshot or whatsoever the question or problem is there, so you can solve that. So we must focus on that. How can we get this end behavior of a function? How will find at the end, just looking by the looking at the graphs, or if we are calculating end behavior using the algebraic methods. So let's see. So please read this one.
Sure. Learn what the end behavior of a polynomial.
Hello.
Yeah, can you hear me?
uh, Now just please, I'm not getting you. Your voice is so weak.
Oh, how about now? Is this better?
Oh yes.
Okay, so I said learn what the end behavior of a polynomial.
Oh, yes. So this is the main thing, that we will learn how to get the end behavior of the polynomials, of the functions. So please read this one.
How we can find how we can find it from the polynomial's equation.
Equation. So let's see. So DLOs. What are DLOs?
DLOs. I don't
Okay.
know what
So
the
here
word
we are
means.
used to what I mean to say, this term, that is, now you can see. So what is that?
Desired learning
Good.
objectives.
So desired learning objectives are for these lessons clearly, as we are looking for how to find the end behavior of any function, any equation. So let's see. We will learn. What we will learn? Yes.
What is the end behavior of a polynomial?
And please read this
Oh,
one.
can you hear
This
me? I
is for
said
you.
how to analyze it from a graph, a polynomial equation.
Equation. So what I have seen from your screenshots, so the graphs were given, and at the end they were asking just to write the answers in the blanks. So we will learn in detail that how to find the what I mean to say, a graph. Just Okay. Now let's see. So these are the main, what we can say, the focusing point, and these are our learning desire objectives. Now let's see. Uh,
Okay,
what's end behavior? So first we will define that.
sure.
Okay. So please read this one.
The end behavior of a function f describes the behavior of the graph of the function at the end of the x-axis.
X-axis. So let me explain a little more. What we can say, just if you are looking at this one, so we can say that the uh, end behavior of a function f describes the behavior of the graph of the function at the ends of the x-axis. So what I mean to say, when the function is given, so we will look its trends, how it is behaving. Either it is going up, down, moving to the left, right, and where. When we are actually putting the values, because there are two variable, one is the dependent and the second one is the independent. So it's very interesting just to look at the graph and just putting the values, and you will be in a better position to draw that graph, or you will be in a better position to talk about its behavior on both ends. Now let's see how we'll
Okay,
do that. So the next is, in other words, please read this one. This is for you.
sure. The end behavior of a function describes the trend of the graph.
Trend of the graph. So we will have to find only the portion of a portion of the graph is shown, and with the help of that we are just getting the equation, and we will put some values and we will know that what is the end behavior, and just looking at the graph, putting some values, making some mental calculation, we will be in a better position to talk about the trends, that where the graph is moving. So let's see. The next is, so if you look to the right end of the x-axis, so the first observation is that we will have to look at the right end of the x-axis as x approaches infinity. So we are just putting the extreme values. So in other words, somebody can say that this is just like to find the extreme values of a function. So as x approaches to positive infinity, that we are moving to the right side of the x-axis. So what will be over there? Now let's see. And to the left end of the x-axis. So both the ends are open. So in this way, first we will go to the right and put the extreme values, and as well as we will put to this that as x approaches minus infinity. So both are the extreme values. So we will observe its behavior. Now let's see what is that. For example, now it's for the better understanding, we are just putting the example. And with this example, you
Okay,
can solve so many problems, because only the equation will be changed, the graph of the function will be changed, but the actual method will remain the same. So let's see. For example, it's a good example just to describe how the trend, what is the trend of the function. So consider this graph of the polynomial function f. So we are talking about the function f, that is, now you can see, I am sure that you can see my figure now. This is a
yes.
graph. Are you looking at this?
Yeah, I'm looking at the graph.
Okay, okay. Now let's see. This time I am just considering its right part. Now this line is actually the graph of a function which is defined as y is equal to fx. That may be any polynomial, any equation, but we are just making it more general to fit on any function. So these are our axes. What we can say, the x-axis, this is the origin, and the y-axis, and this is going on the negative side, and this is on the right hand side. So here we are focusing. Now let's see. The graph is moving just like that, coming down and then crossing the x-axis, and this is moving upward, and we don't know where it will end. But if you are just looking at this, that if we are increasing the values, if we are just going to the right of the x-axis, putting the values, x gets more positive. What I mean to say, that starting from 0 and here the values are increasing, x is increasing, so x gets more plus 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 plus. So if we are reaching at the infinity, let's suppose the infinity is going on, the arrow is what the story is telling, that it's going on, moving on to the right. But if you are just considering this instant, that look at this, fx gets more plus, more plus mean that it is when you are increasing the values, when you are moving to the right, if you are getting more positive values
Right.
for the x, so the graph is moving up, up and up. And it will, what I mean to say, whenever the x is increasing, so for every increase of x, it's going up. For every value, you can see from here, here, anywhere. So at the end, so it will just having the trend to tilt to the right. What I mean to say, that this will go in this way, this way, this way, this way, and this. So it will go up. The general trend, the dominant trend is when you are increasing x, it is going upward. So fx gets more positive wise. What I mean to say, it's going along the y-axis upward. So you are increasing the value of x over here, you are getting the value of increased y over here. So this is from the right side. Now the next figure is that if you are just moving to the, what I mean to say, the next one, that is, notice that as we move to the right on the x-axis, as we have seen in the previous diagram, the graph of f goes up. Okay, moving to the right on the x-axis,
Okay.
the graph is moving up, and
Right.
that is, this means as x gets larger and larger, fx gets larger and larger as well. So we can say it's directly proportional. So when x is increasing, if you are moving to the right, the value of fx, the given function, is also increasing, and its value is becoming larger and larger. Now let's see, if we are just going to see this one mathematically. How can we describe mathematically? Now look at this. We write in this way, that as x tends to plus infinity, positive infinity, then fx also approaches to positive infinity. So increasing trend is there. So whenever the function is given, the graph is given, and you are asked to write its equation, it's what we can say, the mathematical expression for the end behavior. So this line is enough to tell the whole story, to write the whole story mathematically. Because in mathematics, we talk in the language of symbols. So it's
Right.
what we can say, this expression is your perfect answer. What I mean to say, that if you are just writing this, that x tends to positive infinity, so our given function, our graph, which is shown in the diagram, is also approaches to positive infinity. So this was what we can say, that this final uh, expression, mathematical expression, will be your perfect answer. Are you getting me?
Okay.
Okay. Now let's see. We are just say as. So how can we say, as x approaches positive infinity, fx approaches positive infinity? So for the easy understanding of this sentence, this expression is enough for the answering about its right trend. It's about its movement along the positive axis. Now let's see, if we are just going to the other way, on the other end, so on the other end of the graph, as we move to the left along the x-axis, imagine x approaches minus infinity. So here on the left of 0, as we know that all the negative values lying on the x-axis, the graph of the f goes down. So it's a downward movement. Now how? Look at this. This means as x gets more and more negative, because we are moving to the left, fx also gets more and more negative. So if we are just putting the values and we are getting the negative values, what I mean to say, if for each and every negative x, we are getting the negative value of fx, at that time, we will face this situation that the fx is also getting the negative. So what will
Okay.
be its trend? Now look at this. The same graph, the same function. Are you looking at this?
Yeah.
So last time we were talking about this portion that was on the right of the x-axis, and we have seen that it is going up. Now we are just moving to the left. So this type of the graph, or just like these graphs, are shown to you, and you will have to just give the answer in one sentence or one statement, algebraic statement. So what you will have to do mentally, that is that you will have to look the left portion of this graph. What I mean to say, from the left of the 0. So here we can say the origin, the 0 is, and we are just increasing the value of x, which what we can say, the negative, get x gets more negative. It's moving to the left of 0, so it's become the zeros negative values and going on along this line, that is a negative x-axis. So if you are putting the values over here in the equation of this graph, so you will feel that at every instant when you are moving left, the graph is also coming down. So graph is coming in this way. So fx gets more negative. What I mean to say, negative mean when the graph is moving up, so it's along the positive y-axis. And if it is
Right.
moving down, you can see this, so it's a negative y-axis. So it will get, fx gets more negative. What I mean to say, coming down. So you will have to just look at the endpoints. That's why we are calling it the end behavior of a graph. Without doing any calculation, we will have to observe its trend, its ending trend. If we are putting the extreme values, if we are increasing the dependent or independent variables, so we are just tracing its trends, its movements. So this is on the left hand side. So let's see what is the next. Mathematically, now mathematically, that was a graphical, uh, the pictorial view of that. So from there we can visualize what the things are going mathematically. Well, let's see. We write as that x tends to negative infinity, then fx over function is also moving or approaches to minus infinity. So we can say just like that. Say As x approaches negative infinity, fx approaches negative infinity also. So check your understanding. Now it's a time to check that if you have all this that I have explained in the previous slides, now you will be in a better position to check it at your own. Now let's see. So this time you can make use of pen and paper also. The reason is this, that if you can draw, if you can make some mental calculation on the paper, so you will be in a better position. Now let's see. I'm sure that you are looking at my screen.
Yeah.
Okay, so if you look on the next one, so you will be in a better position to get the immediate answer. What I mean to say, look at this. So this is the graph y is equal to gx. What is the end behavior of g?
So from what I remember, it's just talking about if it's negative, right? So it's negative infinity.
No,
X is
if you are
going to
just
negative
moving
infinity
to the, what I mean to say, if
because it's to the right. It's
taking the
going
right
negative.
right portion of, so what is going on over here?
Well, it drops down,
If you are
goes
moving,
negative.
if you are increasing x, what's going on?
The y is decreasing.
Okay. So extreme, you can say that at some instant, if you are increasing the x, so it's going up, then at the end, what I mean to show, it is crossing the x-axis. And if you are increasing x, it's coming down and down and down. So for the extreme values, what I mean to say, that if x approaches to infinity, so it will move down. It will never go up. So this function, what I mean to say, on the right, it is moving down. If you are putting positive x, so you are getting the negative values. So it will move down to the negative infinity. And if you are just looking at this one, so at these 2 points, it's crossing the x-axis. So when you are putting negative values for x, so it's coming down, and then at some instant it is moving up. So you are increasing the negative values, you are moving to the left, so it will go up and up. It will go up and up. So
Okay.
for the negative infinity, it will gx will approaches to positive infinity. Am I right?
Yeah.
So as you are increasing negative values, so minus infinity, do you are moving in this way, your graph is also moving upward. So here, that was the quite contrast between the previous one and this one. That was going up and this is going down, and then on the negative side, it is going, what I can say, that moving up. Now let's see. So look at this. These are the four options. Although we have talked about in detail, but if you're asked to instantly select A, B, C, D, so which is the best fit to that graph, which you have seen just now? For your eyes only, I can just show you again. So if you can look at this, so what you will have to do, that you will have to check the behavior, check your understanding that this is the graph, and you can look at this, and after looking, so you will have to respond A, B, C, and D. What's your choice?
Um, hold on. I'm gonna go with C.
C. Okay. C is just like that, that if x approaches to positive infinity, gx is approaching to minus infinity. And x tends to minus infinity, gx tends to positive infinity. So out of these choices, your choice is C. Now let's see. So this was the graph, and now what you can see that at the right, x gets more positive, gx gets more negative. It's coming down, and from here you can see x gets more negative and gx gets more positive. So you are moving to the left, your graph is moving up. So you have selected C. So let's see. Moving to the right along the x-axis, we see that the graph of gx moves down. And this means as x approaches positive infinity, gx approaches negative infinity. And on the other hand, moving to the left along the x-axis, we see that the graph of g moves up as we were looking at the graph. So from these two statements, this means as x approaches minus infinity, gx approaches positive
Positive infinity.
infinity. And one thing more, this corresponds to the following end behavior. That is what that you have selected C. Now, I am sure that you are absolutely right, but we are just looking at this.
Yeah.
So, that was your choice, I am sure.
Yeah.
So, in this way, uh, what we can say from the delta math, you can find so many questions, so many graphs. I have gone through all those, and I have selected a few ones because there is just the mental calculation, just the observation of the graph and its trends. So out of the four statements are sometimes the blackened space is given and you will have to put your answer over there on that box. So the best fit is what I mean to say, it is the best format just to fill the that block, or you will have to select in this way. So if you are selecting C or this block, so you will get the absolutely right answer. So that is, I am just pasting this style over here, that is from the delta mathematics, that you can just get so many answers, so many functions are given over there, and few you have sent to me. So that was how to get the end behavior to select from these MCQs, these multiple choices. Now let's see. One thing is that is just coming to you. Determining, okay. So this is the other side of the story. What is that? Please read this one.
Determining end behavior algebraically.
Algebraically. So that was actually the graphical, that we are just looking the graph and we will have to select the right options, or we will have to fill the blanks over there. But if the graph is not given, so algebraically we will have to solve that problem. So what should be the line of action? So here I am just writing each and every step in detail. That is for this purpose, that when you will go through all these, so you will be in a better position to solve so many questions. So you will be in a better position to talk about the trends or end behavior of so many graphs algebraically. When the pictorial view is not available, only the equations are given. So you will have to be more, what I mean to say, calculative, or you will have to use your calculation and you will get the answer right. Okay,
Okay.
let's see. We can also determine the end behavior of a polynomial function from its equation. If the equation is given and there is no graph, no pictorial view, so what we'll have to do? This is often helpful while trying to graph the function. So this actually this end is that if you're asked to graph the function when the equations are given and you are just looking for the graph. So what you will have to do, if you know the end behavior, you will be in a better position to locate your graph or draw your graph practically. So that's why this algebraically finding of the end behavior of the functions are very important. A maximum of the time we are asked to draw the graph of the given functions. So that's why this is very important to know the tricks and the techniques and few tips.
Right.
As knowing the end behavior helps us visualize the graph at the ends. So we will have to visualize, and how we'll do that. So to determine the end behavior of a polynomial f from its equation, we can think about the function values for large positive and large negative values of x. So instead of moving left to right or from right to left, we will have to put the values of x. So each and every time we will put the independent values, and then at the end, solving with those maximum values, we will have to visualize that where the trend is going, what we are getting. If we are putting the positive values, what is the final outcome of the function? And if you are putting the negative values, so what is the trend of the function? What the end product we are getting? Because function is the input and the output, the combination.
Yeah.
So let's see. Especially, we answer the following two questions. So before deciding, we will have to answer these questions. The as x tends to positive infinity, what does fx approaches? So when the equation is given, so we will have to investigate when we are increasing the value of x to the right, that is up to the positive infinity, what we are getting, fx, what is the where it is going, what the values are coming, what is the trend of those values, either it is increasing or decreasing or whatsoever the case is. So that is the first step. Next, as x, and then second is that as x minus infinity. So what
Right.
does x, what does fx approaches? So as we were looking for that, that if you are putting the positive values and now we are putting the negative values for x, so what is the approach, where it is going? Either fx is getting lesser or lesser, or it's becoming greater or greater. Let's see. So investigation. Now we will solve the example. So how we can investigate the end behavior or the trend of the graph on both sides of the axis. End behavior of the monomials. So these are all type of the equations.
All right.
Please read this one.
Monomial functions are polynomials of the form y is equal to ax to the power of n.
N. So these type of the equations will be given. Those are the polynomials, and for these type of the equations, we will have to find their graph or their end behavior. Now let's see. Where a is a real number and n is a non-negative integer. So here, this is the power, this is the exponent, that is non-negative, and a is any real number. That may be positive or negative. That may be positive or negative, but n is positive here. We are considering n is a positive. So consider the monomial. Let's see that is, for example, that the fx is equal to x square. Very simple one. So we are calculating, we are looking for the end behavior or the trends of the graph when the equations are given. So this is all algebraically. So graphically we have seen how to find. Now we are just doing the example how to find the end behavior of a graph when the algebraic equation is given for that function. So look at this.
Okay.
For every large positive x values, what best describes fx? Question is for you. So you can answer, you can guess, you can respond for this.
So
For
wait, for every large positive x value, what best describes fx? So it after getting squared, um, it's a well positive.
increasing, you can see increasing. It's greater and greater. Now let's see.
Yeah,
Because
because it can't
positive
be
x,
negative.
choose one answer. So
Okay.
now you will have to be calculative. You can make the calculation also on paper. So fx is that the question was what I mean to say that was the this one fx. So consider this polynomial, this function, and keeping this, you can write down this one. Fx is equal to x square, and the question is this. And now we are just going to solve this. So you can choose one answer. Which one? This one, fx is a large positive number or fx is a large negative number. So out of these A and B's, what is your answer? Your
Wait, it's only
choice.
A and B, right?
Both?
It's only A and B. Like those
Y-
are the only options.
Yes, yes.
Okay, so then it's A because it can't be negative.
Okay. Because it cannot be negative because we have a scale and we have even power. So that's why A is the best fit answer. The square of a large positive number is a large positive. It's a little explanation of your answer. Your answer is absolutely right. But how we are getting this instantly, keeping these things in mind. The square of a large positive number is a large positive number, and the square of a large negative number is again a large positive number. Okay, this is the more interesting because we have a negative x, but we have a positive power, and that is also even. And you know that when anything negative or positive raised to the even power, that will minus will diminish. So there is no question of negative. But on the other hand, if you have odd power, the exponent is odd, n is odd, then positive will be positive and negative will be positive. But in our situation, in this particular question, in this polynomial, y is equal to fx. So scare, fx scare. So scare, that's why what we are getting each and everything positive and larger. Either we are selecting x is negative or positive. So
Okay.
whatsoever the case is, but the answer is larger positive value on both end. So your choice was absolutely right. That
Okay.
was. So for large positive x values, fx is a large positive number. And for large negative values, fx is a large positive number. And that's why what we can say the graph of y is equal to x square verifies this. Okay, look at this. So this is what we can say the pictorial view of that graph. So if you are asked to draw the graph also, so look at this. That was the equation, the graph of y is equal to x square verifies this. Look at this. If you are putting 0, so you are over here touching both the axes at the origin. And if you are moving to the right, what I mean to say, this is the right, you are putting the positive values for x. So you are putting plus infinity, your graph is moving up. Am I right? Can you see
Yeah.
this? And if you are moving to the left of 0 on the negative side of the x-axis, so once again you are increasing the negative values for x. That's mean that you are moving to the minus infinity. X moves to minus infinity. But your answer is becoming positive, it's going up. So in this way, you will get this one, and this is the equation of a polynomial y is equal to x square, and that x square is actually, this is the parabola. It's a special type of the curve that describes the quadratic equation, and it's a quadratic because the power is 2. So it's tracing a parabola having the vertex at the origin. Vertex is this point, and this y-axis is the line of symmetry. So definitely we'll talk about the parabola. A lot of things are over there. So definitely very soon I will get all those slides right to discuss with you. Anyhow, at this time, what we're talking about, that is all about the end point or end values. So, in other words, as x approaches to plus infinity, fx approaches to plus infinity, and as x approaches to negative infinity, fx once again approaches to positive infinity. So, in this way, we can describe that behavior of the last seen graph.
Okay.
Concluding. Now, our conclusion is that we are just going to end this lesson. So, at the end, these are very important just to keep these things in your mind. Very briefly, the investigation, that is, notice how the degree n of the polynomial and the leading coefficient a, so affect the end behavior. So I would like to hear you. Please read this one.
Sure. When the n is even, the behavior of the function at both ends is the same.
Okay, the same. How it will be same?
The
Yes,
sign of the leading coefficient determines whether they both approach positive infinity or whether they both approach negative infinity.
yes. The sign of the leading coefficient, that is a, x and
Yeah.
square. So a is the leading coefficient.
When n is odd, the behavior of the function ends is opposite.
Opposite. Okay, because n is odd, so you'll get the positive and the negative values as well. But if n is even, then you will get both and same.
The sign of the leading coefficient determines which one is positive infinity and which one's negative
Yes.
infinity.
So this will tell you where you will have to go. So what the behavior of n and the leading coefficient a? So we are just making a small summary of this discussion. That is, look at this. End behavior of polynomial fx a xn. This was the leading coefficient a, and this is the exponent n, and this is x. So look at this. N is even, then a is and a is greater than 0. Both are positive. What I mean to say, that this leading coefficient, because this is the equation of the parabola, you can say fx is equal to 2x n plus b, or whatsoever the format is. But if you are looking at this a, so this is positive and x is even, then you will get this graph, because every time on both side it will be going up because n is even and a is positive. So that's why the graph is opening upward. This is upward parabola. And you can say
Okay.
that as x tends to minus infinity, fx tends to positive infinity. As x tends to plus infinity, fx approaches to positive infinity. And over here, the second situation is just like that, that n is still even number, but this time you have a negative a. What I mean to say that a is less than 0. Then you will get this type of the graph. Looking at the graph, you will have to decide that this is coming down, open downward. So as x tends to minus infinity, fx approaches to minus infinity as well, because n is even but a is negative. So after solving this, you will have to multiply with a negative number. So you will get the fx, the end value is negative. Are you getting this?
Yeah.
Because n is even still, it's a even, but this leading coefficient is negative. So this will make the value, final value, negative. So if you are increasing x, you are moving to the infinity here whatsoever, infinity, and then due to this negative multiple, this leading coefficient, that is negative. So this will make it whole as a negative. So this will,
Okay.
although it's a positive, but it's going downward on the right. And x approaches to plus if you are putting the positive values, and n is even, but due to this leading coefficient, it's a less than 0, it's a negative 1, so it will make it negative. So either you are on the left side of the origin, or if you are moving right on the x-axis, in both the cases it's moving down. We are getting the negative values. It's a
Right.
totally contrast to this one. So that's why we can say that the shape of the graph or trend of the graph is depending upon n, this exponent, and also the leading coefficient, which is multiplying with this whole function. So this is what we can say. These are the two cases. And one more is, now look at the odd. When n is odd and a is positive. Now leading coefficient is positive, and now you have n is odd. Look at this. As x tends to minus infinity, and fx also tends to minus infinity. You can see this one
Right. Yeah.
shown over here, because you have the negative value and n is odd. So odd will preserve the negative, negative will come out as it is, and now this a is positive, so positive and negative will be negative. So if you are putting the negative values, even then the graph is coming down, 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 and in this way for the extreme values, for the end behaviors. And similarly, if you are putting the positive axis, n is odd and a is also positive, so this will make all the things going up. You are getting the positive values of the whole function fx. So this is the case. And when n is odd but a is less than, what I mean to say, a is less than now, a is negative now. So minus
Right.
infinity and fx and minus, that will become positive. So fx approaches positive infinity. As you can see that if you are putting the negative x, n is odd, negative is coming out, but the leading coefficient is also negative. So negative and negative will become positive. So this trend will go in this way. If you are putting the positive value and n is odd, you are getting fx positive, but due to this leading coefficient, you will have to multiply with a negative number because its is less than 0. So here you will get the negative answer at the end. So negative output is coming over here. Although you are moving to the right, you are putting the positive values of x, and you are just coming down. So it's a totally contrast to this one. So from here we can say that the behavior or endpoint of the polynomial depends upon two values. One is the leading coefficient and second is the exponent. Am I right?
Yeah.
Okay. So I'm sure that now you will be in a better position to solve all those graphs which you sent to me about the end behavior. Is it?
About what?
Isn't what I'm saying that now after looking these slides you will be in better position to solve all those graphs
Yeah.
because now you have before deciding now you have something in the back of your mind that if you are looking for the end behavior, so you will have to go to the right, put the positive x and what is the trend is. And if the polynomial is given x having some power and is also multiplying with some number, so you will have to once again algebraically look at that and you will be in a better position. I'm sure that you can solve many more these graphs. Am I
Yeah.
right?
Yeah.
And you can answer all those questions which were given in the screenshots, especially when you are asked to find the end behavior
Yeah.
of the given graph, and you will have to fill some boxes and you will put the right symbol in the right box. Okay,
Okay.
just do that. And even then if you are finding some problem, so you can talk to me, you can just text the message, you can WhatsApp that problem. I will come with the right solution. And
Okay.
next time we'll talk about the even and odd function and the composition of the functions and a few things more. And in that way that you will be clear, crystal clear about the graphing of the graph of the functions and all those queries which you are just screening, getting the screenshots and sending me. So I think so it's a time to say goodbye. Allah Hafiz.
Okay.
Thank you
Allah
very
Hafiz.
much. Anything you want to ask, you can just send me the text. So, okay,
Okay, I
I'll
will.
send the message. Okay, thank you very much. Allah Hafiz.
Allah Hafiz.